All right, so this introduction is going to introduce the principles of UV coordinate system in Rhino and Grasshopper, and we'll illustrate the difference between kind of an XYZ point, or a point in Cartesian space, and a point on a surface, and how to locate those. So in Grasshopper, for those who are kind of unfamiliar with it, there's all of these tabs at the top that we can use to drop in what are called components that we can connect with these wires. And there's inputs and outputs for each component. Grasshopper reads from left to right, and we're going to assemble a definition. This is called a definition, and it's going to read from left to right. So that's what we're going to do to start things off. And we're going to introduce this idea of both Cartesian space, so XYZ coordinate system, which Rhino uses, and the UV surface. So we're going to start in Rhino, and we're just going to create a surface. So I'm going to create a plane. So if you type plane, enter, and then click twice, you'll end up with a plane in 3D. All right, so in Grasshopper, what we want to do is create a series of curves based on this surface. So let's say we want to have this surface subdivided with curves. And just to illustrate this, I'm going to click on the surface, and I'm going to hit F10 on my keyboard. Okay, so I created a surface, I hit F10 or points on, and I lifted up two of the corners just to illustrate the three-dimensionality of this. So what I want to be able to do is extract all of what are called the isocurves from this surface. Okay, so I'm going to create a series of stripes on this surface in Grasshopper. Okay, so I have a surface. What I'm going to first do is associate this surface with a surface in Grasshopper. So under the geometry tab, and this is under the params toolbar, if I go down to surface right here, click on that, and then click on the canvas. So we've dropped it into the canvas, and I can use my scroll wheel to zoom. I can use right click to pan. So this is now a surface parameter. So we can associate this with a surface in Rhino. So I'm first going to select it so that it turns green. I'm going to right click it and say set one surface. Click on that surface in Rhino. And now both have turned green. So when I select it, it turns green, and so does the Rhino geometry. So just to map out what our game plan is here, what I want to do is my end result needs to be a series of isocurves that follows the topology of this surface perfectly. So we want a series of curves that follows the surface. Okay, so before we start any kind of Grasshopper definition, it's important to write out the pseudocode or come up with a game plan. Okay, so I'm just going to open up a Word document here. And if we're going to write out the pseudocode, and again, this is kind of the roadmap that we're going to follow. So step one is going to be introduce the surface. So bring in surface. Step two is going to be to create a series of points along one of the edges. Okay, because we're going to use these points to extract isocurves. So we're going to create points along one edge. And those points, when they first come in, those points are going to be in the XYZ Cartesian coordinate system. They're going to be in XYZ space. So we have to find a way to take those points from XYZ space and associate them with the UV coordinate system. So we're going to add convert Cartesian points to UV points on the surface. Okay, so again, this is the roadmap. I'm just writing this out so that you have an example of how to do this for future Grasshopper definitions. So once we get those into UV coordinate systems, we're going to use the isocurve component to create a curve on the surface from each UV point. So isocurve component to create curves on surface. Okay, and that's our goal. So that's the kind of targeted outcome here. All right, and there's going to be a few steps in between 1 and 2. Once we import that surface, we're going to have to grab one of these edges. So to do that, we're going to have to take the surface and extract one of the edges. Okay, so we're going to have to do a deconstruct of that surface, or of that BREP. So in between these, we're going to say deconstruct BREP. And once we do that, so what that deconstructed BREP is going to have is it'll have a surface, it'll have control points, and it'll have 4 edges. We just want one of the edges. So we're going to say extract one of those edges here. And from there, once we've extracted that edge, then we can say, okay, we're going to create points or subdivide that edge. Okay, so this is our roadmap. I'll minimize that. So the first step we've already done. We've brought the surface into Grasshopper. We right-clicked, we hit set one surface. It's now associated. I'm going to now deconstruct this surface. Again, following our roadmap, deconstruct BREP. So if I double-click and I just start typing, let's see. Let's forget the actual term. I think it's this one, deconstruct BREP. Okay, so under surface, you'll see deconstruct BREP. So whenever you bring in a component, mouse over each of the inputs and the outputs and understand what it's producing. If you mouse over the middle of it, it'll also give you kind of a definition of what it does. So it deconstructs a BREP into its constituent parts. So a BREP is another term for a polysurface. So in this case, we just have one surface. It's just going to extract. So if I just click and drag, I've connected it. It's going to extract the faces of that BREP, the edges, and the vertices. Which one of these are we interested in, if you remember? The edges, yeah. So we want to extract the edges. So if I mouse over this, it'll tell you how many values it's getting. So it's getting 4 edges. So we have 4 edges of that surface. We want just one of them. So we're going to use an item index. So I'm going to go to set list and list item. And I can also double click on the canvas and just type item and click on list item. So what this does is it grabs one item out of a list, which is what we want, right? Because we have a list of 4 edges and we want one of them. So again, mousing over, what it's looking for is it's asking for a base list, and then it's also asking for the item index. So every item in a list will have an index, basically a number associated with that object. So Grasshopper starts counting at 0. So the 0 is always the first one, and then 1 is the second, 2 is the third. You'll get the hang of it. But edges of the brep, we want to plug that into the list. So these are all of the edges. That's our total list, but we want to extract just one of those. And to do that, there's a few different ways that we can give this value, give this input a number. So I could right click on it. I can say set integer and give it a number, right? I could give it 0, 1, 2, or 3, and that'll associate with one of these. Or I could double click and create a slider. So sliders are under params. You'll see this input tab and slider. The other way to get this is to double click on the canvas and just start typing a number. So I double clicked and hit 3. And you'll notice when I just bring in a slider, it's I can toggle this from 0 to 1, and this has 3 decimal places. I can right click this and say edit, and I can change the settings for the slider. So let's say I wanted my max to be 3 and my minimum to be 0. I want these to be integers. I don't want to have a floating decimal. And I can hit OK. And so now I have a number slider from 0, 1, 2, and 3. So I can delete this one. Okay, because again, Grasshopper starts counting at 0. And what this will allow me to do is I can plug this in to the item index. So now I have a list of edges. And what this is going to do is it's going to extract this specific edge. And if you notice, it's kind of subtle, but as I toggle this with this selected, you'll see the different edges are highlighting in green. If I want to hide all of these from being red, so I don't want to visualize any of this, I can select them, right click on the canvas and say preview off. So now they no longer turn green. And if I select this, I can more easily kind of see each of these edges being selected as I toggle the slider. Okay, so I'm grabbing different edges. All right, so let's say I want edge 0, right? That's this one. So I have that selected, and if I mouse over this output, this is that edge. So it's outputting this one edge. So referring back to my pseudocode, after I've extracted that edge, I'm going to create points along that edge. So I'm going to use, there's a few ways to do this. If you go to curve, division, you can go to divide curve and click on divide curve. And so what this is asking for is it's asking for a curve to divide. It's asking for the number of segments. So how many segments do I want that curve split into? And this K, which split segments at kinks. So if there's a polyline, it'll split the polyline every time it changes direction, which we don't need to worry about yet. So the first thing we can satisfy this. So curve to divide, we're going to plug in our curve. And you'll see that it went from orange to now it's gray. So it means it's getting information and it's running. And now if we see this edge, it's being subdivided 10 times. So 10 is the default for this number of segments. So if I mouse over this, this component came with a default here. So by default, it's set to 10. I'm going to say 12. So I'm going to double click, type 12, click, and now I have a slider with the value 12, and it'll default the bounds from 0 to 100, which again, we can play with if we right click it and go to edit. We can change the minimum and maximum. We can change the number of decimal points, or if we want it to be an integer. Okay, so bring this slider down to maybe 15, and then plug that into the number of segments. So now we have 15 segments. So not the number of points, but the number of segments of that curve that are now being created. And these are points in XYZ space. If I mouse over what it's outputting, the P, you'll see that it's listing points in XYZ coordinates. It's listing that same coordinate system we were talking about earlier, where it lists the Cartesian coordinates of each point. So going back to our pseudocode, we have these points along the edge. Now we have to convert them to Cartesian points. So points on we have to convert them to UV surface points. Okay, so to do that, there's a component in Grasshopper called surface closest point. So what it's going to do is it's going to say, okay, I see these points in the XYZ, but give me the closest point on the surface to each of these points. So I'm going to double click and type surface, actually you could just go srf cp, and you'll see this component surface closest point. You can also get there by going to surface, and one of these will have it, yeah, here. If you go to surface closest point, it's under surface analysis. It's right here. Okay, so what this is going to output is it's going to actually give me the UV coordinate as the result. So it simply asks for the sample point, which I have my points right here, so I'm going to plug that in. So I have my points, and then it's asking for the surface on which to calculate the UV. So I'm going to plug in my original surface into that. So I have my points in the Cartesian space that in XYZ. I have my surface. And if I ever want to see kind of, if I want to see what's coming out of this before I plug it in, I can add a panel. So under params, this yellow thing is called a panel. I can click on that. And this is basically it's like a looking glass to see what's coming out of something. So I can drag this in, expand this, and you'll see that all of these points are in Cartesian space in the XYZ. All right, so that's why there's 3 values here. If I do that same thing over here, so I'm going to click on panel, open this up, and you'll notice it's outputting these UV coordinates. So I'm going to plug that in. So these are also, they have these 3 values, but this is based on a surface now. So notice how these numbers are different from these numbers, right? Like it's starting out, this point number 0, which is the first one, is at 0, 0, 0. So that's likely this point here, right? So it's starting at the 0 of the surface, but that 0 of the surface has these coordinates in XYZ in the Cartesian grid. So the same points in space have 2 different coordinate systems, the XYZ and the UV. All right, so this is just an illustration of the same point has 2 different ways of calculating its location. So I'm going to delete these. That was just for illustration purposes. But once we have those UV points, we can now use the isocurve component. I always just type this. So I'm going to double click and just type isocurve. Click on that. What this is going to do is it's going to create a curve based on a specific UV value, right? So this needs a UV. That's the whole reason we had to convert this to UV. So it asks for the original surface. So I'm going to plug in the surface into this. And it's asking for the UV coordinates on which to draw curves. So I'm going to plug in my UV points into that. And you'll notice it creates a series of curves on the surface. And you'll notice that it has curves running in both directions, both in the U value, and if I mouse over this, there's 16 curves there, it says. If I mouse over the V, it says there's 16 curves in the V direction as well. So these are visible. So what it's saying is for each of these points, draw a curve in both the U and in the V direction. So what I'm going to get is a bunch of values that are going in this direction and 16 values that are running in this direction, but they overlap. So if I want to see what I'm getting, I can create a curve input parameter. So I'm going to double click and just type CRV for curve. Just drop in this black parameter one. And I'm going to plug that into the U and just see if I click on this, do these turn green? No. So I'm going to plug in the V to that, and now it turns green. So the correct curves are being extracted here. All right, so now I have the curves that are associated with the isocurves on that surface. If I go in and I change the number of division points, you'll see that those curves are updating in real time. So that's the beauty of Grasshopper, is you can look at these changes parametrically. And then from those curves, you can extrude them, or you could do whatever you want to these curves. So let's extrude them. So I'm going to double click and type extrude. Use this bottom one, extrude. And the extrude component asks for two things. It asks for the profile surface, so that's going to be our curve. And it asks for an extrusion direction. So I'm going to plug in the curve to B, which is our profile. And then the direction, if we want this to extrude up, what would we input here? Yeah, we're going to input the Z direction. So I can input a vector into this. Under the vector tab, you'll notice that there is a Z vector. Click on Z. And I can plug that in. And by default, it's extruding it 1 unit. So whatever your units are set to in Rhino, it's extruding 1 foot, 1 millimeter, whatever your units are. So I can plug in a number to this Z and have it controlled parametrically with a slider. So I'm going to double click and type 5.25. And what I end up with is a slider with 2 decimal places. So whatever number you put in, however number decimal places it has, that'll be what it creates as far as a slider. So I'm going to plug that into my Z component, and I'll see that it's extruding all of these curves, whatever that value is. And then to bring this geometry into Rhino, I select the component that I want to bring in, I middle mouse click and I click on this icon to bake it. And now I can definitely save your Grasshopper file. Always save these. Save your Grasshopper file. I would save your Rhino file as well. But you can close Grasshopper. You can bring it back. It's more like minimizing it. But now you'll see that there's geometry in Rhino that you can edit. And again, going back to Grasshopper, let's say I wanted to come up with a number of different versions of this design. I could select this. I could hold Alt and drag my gumball. I could right click on surface, set one surface, and associate it with this one. I can select it and hit points on and then manipulate each of these control points. And I could bake all of those surfaces. So I could select this, middle mouse click, bake, and do that. So if I'm iterating and coming up with a bunch of different options, this is one way that you can do that. And again, the idea was taking a surface, deconstructing it, extracting one edge, creating division points along it, and then converting those points from Cartesian points, which are X, Y, Z, to UV points. And then from those UV points, extracting isocurves from those points. The other thing I'm going to show you is how to create a basically a patchwork of surfaces from that original surface. So I'm going to take this, hold Alt, drag the gumball, move it over. If I want to hide this, I can select all of it and right click and say preview off if I don't want to see it. I can right click and say disable if I want to stop the computer from calculating it. So if this is a really elaborate definition, it's taking up a lot of memory, I can disable it to kind of free up some memory for the rest of the script I'm going to write. So I have this original surface. What I want to do is create a patchwork of smaller surfaces on this. So I'm going to first associate this surface with Grasshopper. So I'm going to double click, type SRF, bring in this surface. Again, under params, geometry, you'll see the surface component here. Same thing. So I have it selected. I'm going to select the component, right click, set one surface, and now it associates with that. So I have my surface, it's associated. And the key component for this one is called IsoTrim. So under the surface component, under utilities, you'll see this component IsoTrim. So what this is going to do, kind of like this icon suggests, it's going to subdivide the surface into divisions. Right? So it'll give me a bunch of panels. It'll panelize the surface. So it asks for a base surface, which we have. I'm going to plug that in. And it asks for a domain. And so if I mouse over this, it's asking for a specific type of domain. So under math domain, you'll see construct domain squared. So this will create a two-dimensional domain with U and V values. So I'm going to plug this in. Make sure I'm actually divide domain. Yeah, it's divide domain, sorry. So if I double click, type divide domain squared, that's the one I'm going to use. So here, divide domain. It's actually this one. All right, so that's going to output a domain that I can plug into this. Notice it's orange because it's not getting data. This isn't getting data because this isn't getting data, so this is orange. And what I'm going to do is give this two different values. So what I'm going to do is set my original surface to be my base domain. And I'm going to input two values here. So I could double click, let's say 12. That'll be the number of divisions in the U direction. Control C, Control V. Plug that in, the number of divisions in the V direction. So I'm going to select this original one because this is getting kind of messy here. Right click, preview off. I could select this, Control H and Rhino to hide, and you'll see that it's creating a grid on that surface. So I can change the number of division points in each direction. And what it's doing is it's dividing in the U direction and in the V direction. And when I'm happy with it, I can select this last component, middle mouse click, and bake. And now I have individual panels for that surface. So if you're creating a facade or some other surface that you want to panelize or extract an individual surface from it, this is the easiest way to get there.